As a spreadsheet, Excel normally works with numerical data. This is why in the area of work I would generally enter numerical, each data in its respective cell. Numerical data are any integer, positive or even decimal numbers that we enter with the comma. They can be negative numbers, for example, this one here. We see that the representation of all of them will depend on their respective characteristics. When entering decimals, I can introduce numerous decimal places. Excel works with a large number of decimal places. It will show me the ones that are meaningful within the column. It might be the case that I introduce percentage numbers, for example, 15 followed by the percentage sign. This is a number, a numerical data, that we represent as 15%. But it is not the number 15, it is the number 15 divided by 100, it is 0.15. But anyway, it is represented exactly as we have introduced it, in percent format but as a numerical data. Since they are also numerical data, for example, also the data referring to monetary units. For example, if I enter 600 euros, the euro symbol, it will recognize that I am trying to introduce the numerical data 600. But that it is also a monetary unit. It accepts it as such and introduces it in the cell with the format that I have defined by default for the currency format. Notice that we have not introduced the space between the amount and the currency symbol. But Excel has put it since it has a defined format for monetary quantities. Okay, also notice that what Excel has really introduced in Excel in this cell is the quantity 600. 600 is a number, independently of whether when I tell Excel when I enter it that it is a monetary quantity. It shows it in the format defined by default for monetary quantities, which is with a euro symbol to the right. This could occur with monetary quantities of other currencies, with dollars, etc. Okay, expressions, for example, expressions that begin with the equals sign are also numerical data. For example, equals sign 3 times 2 is the quantity 6. It is a numerical data and it shows me as such in the Excel cell. However, the content, what is truly in this position, what is expressed here, is the formula or expression 3 times 2. Excel lets us work with fractions too. For example, if we put the expression 1 divided by 4, which is 1/4, well, it is 0.25, it is the unit divided between 4 parts. 0.25, and it puts it with the decimal places that are necessary. Okay, nevertheless, on many occasions we will want to use or work with numerical quantities expressed as fractions. We can do this very easily by introducing a 0, for example, the same value 0.25, 1/4. We would put 0 space 1 divided by 4. In this way we are telling it that we want to introduce this data, but to show it to us as a fraction. The amount is the same, but now we show it explicitly as a quarter. Similarly, we could put, for example, 0.2/4. Okay, the quantity 2/4 is very similar. It can also be expressed as a fraction. The thing here is that Excel goes a step further, and what it does is it also simplifies. It sees that the fraction 2/4 can be reduced, that it can be expressed more simply, more simplified. As a half, and here we have after these amounts are a half will be 0.5, a quarter be 0.25. When we start working, performing operations with all of them, there will be no issue with Excel treating it independently. And then the final result will be displayed in the most suitable way. Okay, all of the numerical data, Excel adjusts them to the right margin of the column, that is, All of these data that we are entering in column A, we see that they are adjusted to their right margin. This criterion is very useful for recognizing, to know in order to differentiate what Excel has understood as a numerical value, distinguishing it from value of another kind, as we will see later, that might include alphanumeric data. So it is very interesting to realize this and the fact that all numerical quantities, Excel is going to introduce them to the right, adjusted to the right. Finally, we should say that in a number, it may have a certain size, but it could be that it doesn't fit in the width allocated to the cell. Unlike other kinds of information, where it is not so important that we see each of the figures in the numerical quantities. Logically, it is very important if we know a figure, we are talking about a totally different number. Which is why when we see this representation, we see that the number introduced in this cell is this large number. But if it does not fit expressed with the typeface that I have defined in this moment, it does not fit in this cell. What Excel will do on many occasions is cross out the number so that we don't see one that it really isn't. Sometimes what Excel can do is, depending on the number that we introduce and on how the cell and column formats are defined, it represents. For example, a very large number, it represents it in scientific format with exponential format, that is. This is the number 1, 234 etc. times 10 raised to 14, that is, that after 1 would come 14 figures, that is, a number of this magnitude. Excel has no problems working with all the figures we have entered. Excel accepts a large number of meaningful figures in numerical quantities, but when showing them it can face some limitations of space, or that we have give it some requirements for showing these data in the working view. So it will show them in a particular way, but will always conserve and make the calculations using the exact number. The same thing applies in this case as in this case. Numerical data, Excel was conceived to handle them, and it will carry out a great number of operations and a great amount of work with this kind of data.